All right, now let's finish up our basic trig identities here, or our trig identities, the foundational ones. We're going to finish up with what are called the double angle identities or double angle formulas. So down here you're going to put double angle. Okay. Well, what do I mean by double angle? Okay, well, we know that theta is the angle measure, right? It's typically referred to the angle we're dealing with as angle theta. Okay, well, as an aside, let's say we're dealing with the number, the number 6. If I said that I didn't want to deal with 6, I wanted to double 6, right? Well, doubling 6 means multiplying by 2, right? So 2 times 6 is 12, and 12 is double 6. So if I want to double theta, I'm just simply going to multiply theta by 2. So 2 theta is double the angle, right? If theta is the angle, then 2 theta is double the angle. I've doubled the angle, which we are just going to call a double angle, okay? There's one sine identity for the double angle, and there's one tangent identity for the double angle. But cosine actually is dealt with 3 identities. So we're going to have the cosine double angle. We're going to say the cosine double angle is equal to this, it's also equal to this, and it's also equal to this. So because cosine has 3 double angles, we're gonna do cosine. We're going to do 3 for cosine. So it ultimately results in 5. 1 for sine, 3 for cosine, and 1 for tangent. Okay. All right. So here's what I mean by double angle. I'll say sine of 2 theta. Now this is really useful in situations where you have you have sine of 2x or something like that. Okay. And so you can take that out and you can replace it with what it is equal to, okay? You'd be amazed at how many situations you wind up with 2 times your variable inside your trigonometric function. This one's a really easy one, but again, you just kind of have to memorize it. Sine of 2 times theta is, that looks a little bit like a 20. I hope that doesn't throw you off. It's sine of 2 theta. That's a theta. Make sure you indicate that as a theta. Is equal to, our formula is 2, or our identity is 2 sine of theta times cosine of theta. That's it. 2 sine of theta, cosine of theta. Okay? All right, so now cosine of 2 theta, all of these are going to be of 2 theta. We have double the angle, right? All right, so cosine of 2 theta is going to be cosine squared of theta minus sine squared of theta, okay? That's pretty simple. Now here's the thing about that is don't mix this up with the Pythagorean identity, okay? This is not, one of them squared plus the other one squared. This is one of them squared. This is cosine squared minus sine squared. Also, don't mix it up. It's not sine squared minus cosine squared. You can't just, subtraction is not commutative. You can't just flip it around if you want to. It doesn't work that way, okay? It has to be cosine squared minus sine squared, okay? All right, now, what we're going to do a little bit later is I'm going to show you why the second one is equal to this one, but the second one is going to be 2 cosine squared of theta minus 1. So cosine of 2 theta is equal to this. It's also equal to this. And the third one that cosine of 2 theta is equal to is 1 minus 2 sine squared of theta. Okay? So all 3 of these identities equal cosine of 2 theta. Our very last identity is tangent of 2 theta. Okay? And that's going to be equal to 2 tangent of theta over 1 minus tangent squared of theta. Okay? The way I think about it is this, it starts off in the very same way that sine starts off. See how sine starts off with sine of 2 theta is 2 sine of theta. Tangent of 2 theta starts off with 2 tangent of theta, right? But then it becomes a fraction, and it's over 1 minus tangent squared of theta, okay? All right, so these are your double angle identities. And in just a minute, like I said, I'm going to show you an identity, kind of a proof identity that shows that these really are all equal to each other. But what I would do now is now that you have all of them, the whole page, I would get another piece of paper out and cut it up into 6 parts. Blank piece of paper, and see if you can write out all of the identities, starting here, these, and then check to see which ones are correct. And then if all the ones that are not correct, fix them with a different color pen or something like that. Then get a new blank sheet of paper out, break it up into 6 boxes, do it again. Then after you're done with that, check your answers, then get a new clean sheet of paper out and do it again, 6 boxes. So go make sure you can memorize all these. Just get them straight from your head, okay? All right, so now what I'm going to do is I'm going to show you how these 3 formulas, why all 3 of these are related to each other. And essentially, I'm going to show you how we prove identities in trigonometry. All right, so what you'll have a lot of times in trigonometry is you'll see something that says, show that one expression is equal to another expression. Show that cosine squared of theta minus sine squared of theta is equal to 1 minus 2 sine squared of theta. All I've done is I've taken this formula for cosine of 2 theta and this formula for cosine of 2 theta. Since they're both equal to cosine of 2 theta, they have to be equal to each other, right? Okay, well now what we're going to do is to show that one expression is equal to another expression, what you essentially have to do is you have to either change both sides until they both look identical, or change one side until it looks like the other side. What I'm going to do in this particular case is I am going to change the left side to look like the right side. So I'm going to leave the right side just like that, okay? All right, so what I'm going to do is I'm actually going to use this sine squared plus cosine squared equals 1. And a lot of times you can use, one of the most useful tools is this Pythagorean identity. Because I've already got cosine squareds and sine squareds here, right? So in order to make this look more like this one has sine in it, but it doesn't, sine squared, but it doesn't have cosine squared. So I want to get rid of cosine squared. The way you get rid of an expression is you find something that it's equal to. So I need something that says cosine squared of theta is equal to that thing. That way I can erase this, or I can cross this out and put in its place the other thing. So I'm going to use this Pythagorean identity right here. And what I'm going to do is I'm going to solve for cosine squared of theta. Well, I can solve for cosine squared of theta by subtracting sine squared of theta from both sides, right? It's algebra, so I have to subtract. If I'm going to subtract something from one side, I have to subtract it from the other side. So minus sine squared of theta. On this side, it's going to cancel, and all I'm going to have left is cosine squared of theta equals. And then over here, I have 1 minus sine squared of theta. So sure enough, I now have that cosine squared of theta is equal to 1 minus sine squared of theta. So now what I can do is I can, in this equation, I can replace cosine squared of theta with 1 minus sine squared of theta. Okay? So on my next layer here, I'm going to replace cosine squared of theta with 1 minus sine squared of theta. That's replacing that. Now, I didn't replace the rest of this. The minus is still there. Minus sine squared of theta equals 1 minus 2 sine of theta. Not changing the right side there. Okay, I'm not changing it. Okay, I don't need that anymore. Now, here I can basically just get rid of the parentheses, because the parentheses aren't being multiplied by anything. It's just 1 minus sine squared of theta, and then outside I have, again, minus sine squared of theta. So I have 1 minus sine squared of theta minus sine squared of theta is equal to 1 minus 2 sine squared of theta. These two basically almost look identical already. I only have one step left. See here, this minus sine squared of theta, minus sine squared of theta, these are like terms. They're both squared, they're both of the same angle, and they're both the same trigonometric function, okay? So it's about the equivalent of having negative x squared minus x squared. Now, you may struggle with this algebraically, or you don't, okay? But this is a negative 1x squared minus 1x squared. And negative 1 minus 1 is negative 2. So this is actually negative 2x squared. Well, in the very same way, what we have here is a negative 1 sine squared of theta minus 1 sine squared of theta. So there's a negative 1 and another minus 1, making it minus 2. So this is 1 minus 2 of these. There are 2 sine square of thetas, right? So this side is 1 minus 2 sine squared of theta. And look what we have over here, the exact same thing. 1 minus 2 sine squared of theta. And we have just verified that this and this are both equal to each other by removing things and putting other things in. And that's basically how trigonometric identities work. What I'm going to do now is I'm going to make a little segment where I show you a few examples of how to show that a trigonometric identity is true or whether the trigonometric identity is false.